Okay, so here's a similar problem. Again, it's a degree 4 polynomial, and we're looking to find all the zeros. Again, we're given a hint that negative 5i is a 0. So we'll divide out the factor. Keep in mind, we also know then for free that if negative 5i is a 0, then x equal to positive 5i is also a 0. Also keep in mind, negative 5i being a 0 means x minus that, which is x plus 5i, is a factor. And then similarly here, if 5i is a 0, x minus 5i is a factor. Okay, so we're dividing out, we'll start by dividing out those two factors. That'll take our degree 4 down to a degree 2. And then hopefully that degree 2 quadratic can either be factored or we'll use the quadratic formula. Okay. First we'll take out this first 0, negative 5i. Again, we write our coefficients, 2, negative 2, 55, negative 50, 125. Again, it gets a little bit messy. Our advantage is we know that that should be 0. So we need, if we do things right, we should wind up with a remainder of 0. So bring down the 2. We multiply, that's negative 10i. Add, one has an i, one doesn't, so we leave it as negative 10 minus 2i. Okay. Now again, we have to multiply negative 5i times negative 2 minus 10i. Okay. That's something you might want to work off on the side. Okay. So we have negative 5i times negative 2 minus 10i. Okay. It's not quite a FOIL, we just have a distribution. So negative 5i times negative 2 is positive 10i. Negative times negative is, again, a positive 50i squared. So that's 10i. Remember, I squared is negative 1, so it becomes minus 50. Okay, so that's our multiplication. I'm going to write it the constant term first. So negative 50 plus the 10i. Add. So you get a positive 5 plus 10i. Again, a similar distribution here. I'll leave that for you to do, but it does turn out to be 50 minus 25i. That adds the negative 50, 50 go to 0, so this is just negative 25i. And then this turns out to be negative 125, right? So negative 5 times negative 25, remember, is positive 125. But you have I times I, or I squared, which is negative 1. Okay, so we do get remainder 0. Again, instead of rewriting or anything at this point, we'll just go ahead and take out our other factor that we know, which is x minus 5i, or 5i is to be a 0. Take these coefficients, so 2, negative 2 minus 10i, 5 plus 10i, and negative 25i. Again, we know this should be a 0, so our remainder should be 0. We'll go ahead and do the synthetic. Bring down the 2, multiply. So that's 10i. Clear, that adds up to be 0, so we just get negative 2. Again, we get a negative 10i. This adds to be 5. There's 25i. And in fact, we do get 0. Okay, so we have our p of x. We factored out the x plus 5i. Then we factored out the x minus 5i. We're now down to a degree 2, which has coefficients 2x squared minus 2x plus 5. So we have 2 of our zeros. We have 2 more buried in here. This, in fact, does not factor, so we'll just use the quadratic formula to get our other 2 zeros. Okay. So again, just remember, we already have the 0 from here, x equal to negative 5i. We have the 0 from here, x equal to 5i. And then we'll have 2 zeros from here that we'll get from our quadratic formula. Okay. And so, again, we're just solving 2x squared minus 2x plus 5 equal to 0 using the quadratic formula. So a is 2, b is negative 2, and c is 5. Okay. So x equals opposite of b, which is positive 2, plus or minus square root of b squared, which is 4, negative 2 squared is 4, minus 4ac all over 2a. So that's 2 plus or minus the square root of 4 minus 40 all over 4, 2 times 2. So it's 2 plus or minus the square root of negative 36 all over 4. We'll clean up just a bit more here. So the I obviously the negative comes out as an I. Square root of 36 is 6. And then we can factor out a 2 to do a cancellation. So we get 1 plus or minus, sorry, I lost my minus there. 1 plus or minus 3i all over 2. Okay, and so our other two zeros would be 1 plus 3i over 2 and 1 minus 3i over 2. And those would be the 4 zeros. Okay, and so in this case, we were looking to find all the zeros for fourth degree, and we have our 4 zeros.